In today's class, we are going to check feature independence in an AI-based email spam detection system. So an AI-based email spam detection system, it classifies emails as spam or not spam using multiple features. So before training the machine learning model, the data scientist, he wants to determine whether the two extracted features are independent. So the two features are email contains the word free. Okay, whether it is yes or no, and why, the random variable y, it is nothing but email contains an attachment, whether it contains or not. So from a large collection of emails, this is a joint probability distribution. Okay, so if an email has the word free and has an attachment, then it is probability 0.12. Likewise, if it has the word free and if it has no attachment, the probability is 0.18. Likewise, if it has the word free is not there and it has an attachment is 0.28, and there is no word free and there is no attachment is 0.42. So for this data, we are going to check whether it is independent or not. So how do we check whether it is independent or not is the joint probability distribution should be equal to the product of the marginal. Okay, that is, this is the joint probability distribution. We have to check whether it is equal to the product of the marginal probability distribution. Okay, so we are going to do this by using the Python code. Okay, so here what we do is we just deal with numbers, arrays. Okay, so we need the package numpy. So we are going to import numpy as np. Okay, now we are going to name this joint probability distribution as j. So j is nothing but np.array. We are just going to give the values as arrays. The first row 0.12 and 0.18 takes inside the square bracket, comma, the second one is given in the other square bracket. Okay, so this is how we have inserted the value of the joint probability distribution. So once this is done, we have to find the marginal probability. So marginal probability of x is nothing but you will add 0.12 and 0.28. That is, it is column wise addition. So in order to do column wise sum, what we do is we give np.sum j. That is, in the joint probability, we are adding the columns. Okay, axis 1 means axis equal to 1 means it is columns. Okay, likewise np.sum j axis equal to 0 means it is row wise. So probability, marginal probability of x is found row wise, sorry, column wise, and marginal probability of y is done row wise. Okay, so once the marginal probability is found, I told you that marginal probability should be equal to the joint probability. So what we do is element by element multiplication. So this is the formula to find the element by element. So np.outer, if I give this command, it computes the outer product of the two vectors. It multiplies every value of p of x with p of y. Okay, because we have to check whether each and every value is similar in the joint probability as well as in the product of the marginal probability. So in order to attain that, we use np.outer. Okay, so in order to see the answer, what we give is print joint probability. That is, it will print these values again. Next one, we are going to print p of x into p of y. Why the slash n means it will leave a one line space before the. So after it types joint probability, this value, it leave one line space. For that one line space only, you are giving this slash n. Okay, so now we are having joint probability and expected. Now this command, we are going to create a loop, if else loop. So if np dot all close j comma expected. So what happens here is it will check each and every value of your expected and your joint that product p of x into p of y. So when checking if each and every value are same, then it will print the two features are independent. If they are not similar, then it will print that the two features are dependent. Okay, so for our program, we just got the output. You can check with the output. First, joint probability. This is the question. We have founded the expected, that is p of x into p of y, element wise multiplication. So after that, you can check both the values are independent, that is equal. So we say that they are independent.